students, a very good morning. So today let's start to discuss the rest of the topic in the case of motion in straight line. So while discussing motion in straight line, we have discussed first of all distance and displacement. Later we have discussed speed and velocity. So let's see now what is accelerated motion. So up to now what we have discussed uniform motion, means whenever the velocity or speed of the body that is uniform, means equal interval of time, that is covering equal displacement or equal distance, then that time that is the motion is known as uniform motion. But here we are talking about the accelerated motion. Accelerated motion actually are non-uniform motion. So let's see what is accelerated motion first. So here just now I have told you accelerated motion or non-uniform motion. So here let's see what is the uniformly accelerated motion and what is non-uniformly. But before that, let's just start from this point. In non-uniform motion of an object, the velocity of object is different at different instant. That is, the velocity of object keeps on changing with time. So such a motion is said to be accelerated motion. So acceleration is exactly what? That is rate of change of velocity. So whenever the velocity is changing with each interval of time, then that time we can say the motion is accelerated. So acceleration you will obtain whenever there is the change in velocity occur. Okay. So next, for example, a vehicle while going from one position to another on a road moves with very different velocities at different instants. So that's why we can say the motion of vehicle is accelerated motion. So here the next one, what is uniformly accelerated and non-uniformly accelerated. So in accelerated motion, if the change in velocity of an object in each unit of time is constant, means if you will see suppose in 5 minutes what is the velocity change, then again in next 5 minutes what is velocity change, if that change is constant, then that time the motion is known as uniformly accelerated. And if that change is not constant, that is changing, that have different values, then that is called non-uniformly accelerated motion. Now let's see the next one, the definition of acceleration now. So acceleration, just now I have told you the definition. Acceleration of an object in motion is defined as the ratio of change in velocity to the corresponding time taken by the object. So you can see here. Now acceleration, if you will see, as it is talking for the velocity, and velocity is vector quantity, so acceleration will also be the vector quantity. If it is positive if the velocity is increasing, and if it is velocity is decreasing, then that time it will be negative. So acceleration can be negative, positive or zero depending on the condition of the change in velocity. So if change will be positive, then acceleration will be positive. Change is negative, then acceleration is negative. Negative means actually the velocity, if it is decreasing, then acceleration is negative. So on the negative acceleration, that is also called by a name, that is called retardation or deacceleration. Now let's see some information about the here acceleration. So information like unit of acceleration, you know already in unit and dimension we have discussed it one. Now let's see how many types of acceleration. So just now we have seen uniform acceleration. So uniform acceleration is what? Whenever in equal amount or equal interval of time, the rate or the change in velocity is equal, then that time that is called uniform. And if it is varying, then that time it is called variable acceleration. And average acceleration is what? Whenever we are going to take the average of the total change in or you can say, if we will just take the ratio of total change in velocity to the total time taken, then that will provide you the average acceleration, just like we have discussed for the average velocity or average speed. One graph you can see, this is the graph between velocity and time. So in this graph, as the motion has started from this point and it is going on, so here you can see now the different points on this graph, and we here 2 points are taken, A and B. A and B you can see. And by with respect to A and B, what is the time? So for point A the time is t1 and velocity is v1. For B point, time is t2, velocity is now v2. So you can see here what is delta v and delta t now. So if you will just calculate the slope of this line, that is just matching the point A and B. So if you will, you can see from if it is making with horizontal the theta angle, then that time we can calculate the slope here, because for that one from A to B, if it is just going in a linear way, so slope of the straight line, that is given by tan theta. And tan theta you can calculate by BC, means perpendicular upon just base. So AC is the base here. So perpendicular will be what? That is equal to delta V. So and delta V is equal to V2 minus V1. Similarly, the base is AC is equal to delta T, or it is T2 minus T1. So this is our average this is our acceleration here, or average magnitude of average acceleration exactly. So simple, you can see from this graph the slope of the straight line joining two point on velocity time graph with time axis gives the average acceleration of the object between them. So if we are plotting the velocity time graph, then that's the slope provide us the value of acceleration. So about average acceleration, I think that is now clear. The fourth type of acceleration, let's see, that is instantaneous acceleration. So what is instantaneous acceleration? So as we know, whenever the object is moving with variable acceleration, then object possesses different acceleration at different time, instant of time. So the acceleration of the object at a given instant of time, or at a given point of motion, is called the instantaneous acceleration. So suppose an object is moving with non-uniform acceleration along a straight line. So if v and v plus delta v be the velocity at the instant t, and t plus delta t. So where delta t v is very small interval, so we have taken only at two time what is the velocities here. So if this time start to tend to 0, then that time we will have the acceleration of the system or particle. So acceleration can be given by simply, this is delta v by delta t. But if we will approximate this relationship by taking delta t tends to 0 and by taking limit, then instantaneous acceleration is given by this value, or we can also write this one dv by dt. So dv by dt is what? This is rate of change of velocity. So the differential rate through which we can also calculate what will be the value of acceleration. So this is the formula of instantaneous acceleration. And as we know, dv is v is equal to ds by dt or dx by dt. So if you will write down that value ddt and then dx by dt, then this is equal to d2x by dt2. So this is the 2 times differentiation of you can say displacement and 1 time differentiation of velocity. So you can find out acceleration by any of the method here. So next one here, if you will see, this is very important line also. Thus instantaneous acceleration is also defined as the slope of the tangents of velocity time graph at a position. So that I have told you already, whenever you are plotting the graph, then that time slope of that graph at any instant of time will provide you the instantaneous acceleration. Here one important point is that you can retain in your mind, that is here, if a body is moving with uniform acceleration, then its average velocity is this one. Means if acceleration is uniform, then average velocity will be simple addition of the simple arithmetic mean of the two velocities here, where u is initial and v is final velocity. Let's see now the formula for uniformly accelerated motion along the straight line. These are very important formula, let's see them. And here alternate method I will tell you also along with this one. So first relation is here velocity time relation, means the equation that is relating velocity and time. So exactly in the formula of accelerated motion, what we are going to do, we are going to relate some of the quantities like velocity, acceleration, time, and the distance traveled. So these four quantities we will relate to each other. Then first relationship we are going to make for the velocity and time. So for this one, suppose a particle that is that starts its motion from t is equal to 0 from point O. After some time at t is equal to t1 it is at A, and at t is equal to t2 it is at t2 B, and the distance from point A from O that is x1, and distance of point B is x2 here. So here you can see what will be the acceleration of the object. So that is change in velocity to the time taken. So velocity is for the velocity in our assumption it is given that the particle that is moving with velocity v1 at point A and with velocity v2 at point B here. So let's see now. Here change in velocity will be what if B to A you have to see. So at B to B velocity is v2, at A velocity is v1. So this will be change in velocity is v2 minus v1, and time taken. Then if time is taken here at B is t2, at A is t1. So t2 minus t1 will be time taken. From here you can write down this line, v2 minus v1 is equal to A t2 minus t1, or you can write down v2 is equal to v1 plus A t2 minus t1. So if now origin of the time axis taken to at A, means if we are taking origin of time axis at A, and u is the velocity of object at A and v is the velocity of object at B, after some time t, then v1 this will be equal to u1, t1 this will becomes now 0 because we have shifted our origin at A, v2 is v and t2 is t. So this equation will be obtained as v is equal to u plus at here. So this is the equation of motion, we are also saying this one, and that helps us to understand or find out the relationship between velocity and acceleration. One more way is here to just find out this one relationship, the calculus method you can adopt. So let's see what is the calculus method. So as we know that A is equal to dv by dt, just now we have seen this one. From here you can just find out dv is equal to A dt. Now as v, if it is starting, suppose the motion as started from the velocity at origin from u, and at final point it is v velocity. So it means that velocity is changing from u to v, and in that change if time is changing from 0 to t, then let's see as acceleration, let's take a uniform acceleration concept. Then acceleration is if it is constant, then we can take here integration in both sides. So if you will just integrate the function on both sides, then as A is constant you can take outside of the integration, so this will be dt now. So as v is varying from where to where, it is varying from u to v, and t is varying from 0 to t here. Now you can integrate this one both sides. So let's integrate this. So first side you will integrate, then dv, that its integration will be equal to b, sorry just a second, and it is now u to b. And next one here as A it is, and we have the t, after integration of dt it will be t now, obviously 1 into dt you can write, and that will be t. Similarly here 1 into dv we can write, and vb will obtain. So 0 to t you will obtain now. So let's write down the now limit. So if you will write down upper limit, then this will be v minus, and if lower limit you will write v minus u, this is equal to A. And if upper limit you will write down, this will be t, and lower limit if you will write, then it will be 0, that will be automatically says. And again if you will just arrange it, then just 1 second, After arranging this one, you can obtain this value, v is equal to u plus at. So this is alternate method, the calculus method that you can adopt also to find out the relationship between velocity and time. So this is the first relationship that we have got. Now let's see the second relationship, that is position time relationship. So if v average be the suppose average velocity of the object during the motion of object from A to B. So v average is given by displacement upon time taken. So displacement is what? That is x2 minus x1. Again you have to see this figure, just note down, just make this figure and just take the help of this one. So it will be x2 minus x1, and the time taken in that one, that is t2 minus t1. So from here you can write down x2 minus x1 is equal to v average t2 minus t1. Now but you know average velocity, that is equal to initial plus final velocity upon 2. So as our acceleration is uniform, for a uniform acceleration, just now I have told you this one. So let's use this formula. So x2 minus x1, in place of v average we can write v1 plus v2 upon 2 and t2 minus t1. So let's solve for x2. So this will be x1 plus this whole formula we will have, and let's arrange them in some simple manner. So if you will arrange them in little simple manner, then that time it will be x1 plus v1 t2 minus t1, then half a t2 minus t1 whole square. Now let's impose the again initial conditions. Initial condition means if our t1 is 0, x1 becomes x0, v1 becomes u, t2 becomes t, x2 becomes x, then this equation will be in this way. And if x minus x0 you will write down in at one position, and that is equal to the x distance travelled in time t, then the final equation will be here s is equal to ut plus half at square. So this is our second equation of motion, that is relating position with the time. One more method is here to find out this relationship. So let's see what is the method through which we can find out this relationship easily now. So for this one case, what you have to do exactly, you have to utilize again the equation of the differential form that we have. So the alternate method that we can adopt again just now by using the first one equation, as first one we had v is equal to u plus at. In the place of v, what we can write? We can write rate of change of displacements. So this is now equal to u plus at. U is as initial speed, that is constant, a is constant here. Now we can write ds, this is equal to u plus at and in bracket dt. Now what we have to do, we have to integrate this whole function on both sides. So if you will just impose the integration sign in both sides and also impose the limit here. Limit is what? The particle start from x is equal to 0, suppose s is equal to 0 to s, and the time taken in this covering the distance s, that is from 0 to t. So let's integrate it and let's put the limit now. So when you will integrate the first portion ds, then that's integration is obtained as s, and as its value is 0 to s. And now if you will integrate u plus at, so if you will integrate first portion u, so there will be 1 into dt, so ut you will obtain, plus one more term you will obtain, that is as at you had, then a you will take common, t its integration is t square by 2, so you will have half at square, and this is now 0 to t. So let's put the limit here. After putting limit, you can see your formula will be s is equal to ut plus half at square. So this is our required relationship, and this is called the second equation of motion. So this is the equation of motion just now we have derived by this relationship. So similarly you can also do it for by yourself for the third one. So let's see first what is the third one relationship, that is relating position and velocity. Now time is disappeared from here. So as we know this is the relationship we have v2 minus v1 by t2 minus t1 is equal to a. So we can just write down t2 minus t1 is equal to v2 minus v1 by a from here, and we have to put in equation 4. Let's see what is the equation 4. So this one is the equation 4, you can see here. So this is our equation 4. So let's put the value in this one equation and solve this. So if you will put, then you can just remove the t from there, and after removing this you can solve the equation. So this equation is obtained as v2 square minus v1 square is equal to 2a x2 minus x1. Now again let's use the initial conditions for v1 is equal to u, v2 is equal to v, x1 is equal to x0, x2 is equal to x. Then this equation is derived in this way, and x0 minus x as it is s, then it means that we will obtain this relationship final, v square minus u square is equal to 2as. So now you can again use the calculus method by yourself here for this kind of situations. So students, I think equation of motion is now clear. Number of questions we have, later we will see also them. So here let's see now some of the velocity time graph of an accelerated motion. So the first graph is plotted when an object is moving with zero acceleration, that is constant velocity. So if acceleration is 0, then you know a is equal to dv by dt. Then if a is equal to 0, so it means that dv by dt is equal to 0, and if you will integrate, then v comes to be constant. So it means that if velocity is constant or acceleration is 0, then that time here with time as velocity will not change. So this is the constant velocity graph here for the first time. Means if there is 0 acceleration, then graph will be of this type. Second one, if when an object is moving with constant positive acceleration having 0 initial velocity. So if you will see, this is the graph for this statement. If the positive acceleration means if you will just find out the slope of velocity time graph, then that will provide you the positive value of slope. So here at any point you can find out the slope of this graph, then you will find out that this is positive value. So it means that its acceleration is positive, and 0 initial velocity means it's that motion is started from 0, the O. So you can see this is the graph B is for this kind of situation. Let's see now the third case. Third case is when an object is moving with positive constant acceleration have some initial velocity. So it's the same problem is here. The before, like if you will just find out the slope of this graph, then this will be positive. So means positive acceleration we have, but now the initial velocity is not 0. Motion is not started from O, but it is started from B already, means the motion has or object has some of the initial velocity. The fourth one, let's see. So fourth one is when object is moving with increasing acceleration having 0 initial velocity. So if acceleration is increasing, means variable acceleration is here. So continuous, if velocity is increasing with time, then it means it is just now I have told you, whenever velocity will increase, acceleration will also increase there. So here for increase and of the velocity, this kind of graph we will have. For fifth one, when object is moving with constant negative acceleration now having positive initial velocity. So if initial velocity is positive, means you will see OE, this is positive. So our motion is started from E, but it is decreasing continuously with time, and ultimately at F it becomes 0. So this is the, if you will find out the slope here, that slope will become negative. So that is the negative slope. The seventh one, let's see the graph, that is when an object is moving with uniform negative acceleration and having negative initial velocity. So negative initial velocity means now its velocity motion is started from this point. So here minus u is the negative initial velocity, and it is continuously decreasing, means minus v is the final value. If it is, then you can find out the slope, that will be negative. Now the last one here, when an object is moving with uniform negative acceleration having positive initial velocity. So if velocity is positive but acceleration is uniform and that is in negative, so continuously it is decreasing. So you can say the graph will be of this type. Similarly, the next one here, the position time graphs for accelerated motion. So if you will find out the first one, when object is moving with uniform positive acceleration, means continuously acceleration is increasing, then that time this kind of graph we will have for the position and time. And if it is it has negative acceleration, means acceleration is decreasing, then this kind of graph we will have. And this kind of graph we have if the acceleration is constant. Now the next one is distance traveled by an object in nth second. So suppose in nth second, if we have to find out what is the distance traveled in second, in 10th second, in 11th second, how can we find out? So let's see now. Here a graph is given in that is the graph between velocity and time. So here this graph, it is obviously you are seeing it has some of the initial velocity u, and acceleration it has some of the uniform acceleration. So let A and B be the 2 points on the velocity time graph as shown in this figure, corresponding to time n-1 and n seconds. So there A and B, you can see now 2 points, and that corresponds for the time n-1 and n. So let Vn-1 and Vn, so Vn-1 and Vn, these are two velocities at these points A and B. So the distance traveled in nth second, dn, this will be equal to distance traveled in n second minus distance traveled in n-1 second. And distance traveled in n second, how can you find out? You can find out by the area of O1, AB, B1. So what is now O1? O, so you can see if I will just remove this one, then now you can find out easily in on the graph what is O1 and AB, B1. So here that is the area traveled in covered in n second minus of area covered in n-1 second. So for n-1 it will be O1 A1, simple. So this is now you have to find out what area of this slope. So if you will see now trapezium, this is, so this is whole of the area of trapezium AB, B1, A1. So if you will find out the area now, then its area can be find out by this method, and you can write down now the values, and final this one is we have obtained. Now as we know, the velocity of object at any time is equal to v is equal to u plus at. So we can what we can write now, just a second, yeah, this one. If you will write down now, Vn is equal to u plus an, and Vn minus 1 is u plus an minus 1, and now you can place these two values in Dn, and if you will solve, then you can find out the distance traveled by any object in nth second. So this is the formula for that type of question. So I think that is now clear. Now next one, let's see motion of an object under free fall. So if any object is released from height near the surface of earth, then it is accelerated downward under the influence of gravity with acceleration equal to acceleration due to gravity. And if air resistance and viscosity, all things we have neglected, then body is said to be in free fall. So that time here if height of through which the object fall is very small compared to radius of earth, then g can be taken into as the constant, because z is varying, but whenever the height is very small in comparison to radius of the earth, then that time it can be taken as constant. So the free fall is the case of motion with uniform acceleration, exactly you can say, where g is taken as 9.8 meter per second square. So this question is now clear. Now next, in the case of free fall, if downward direction is taken as positive, you can take downward or upward both as positive. So if downward is taken as positive, then the object released from rest, then u will be 0, a is equal to z, t is equal to t, and s is equal to t. Then you can write down the equation of motions as v is equal to, we had u plus at. So in the place of u, you can write 0. In place of a, you can write z. So this will be u is v is equal to gt. Similarly, this will be s is equal to half gt square. This will be 2gs. Now if we will take the downward motion as negative, then for object here a will be minus of g. So this equation will become this value. You can write down this values now. So here if you will see now the variation of acceleration with time for free fall, Then the first graph is showing us the variation of acceleration with time for the free fall case. So as here g is acceleration is taken as minus g. So this is the continuous, g is constant, and our body is free falling. For the second one case, here this is the velocity time graph for the free fall. So this is same graph actually, but it is in velocity and time, and this is in distance in time. So for all these three graphs, you can see this is position time graph, this is velocity time graph, this is acceleration time graph, and that all three graphs are for the free fall case. Now students, let's see the next topic, that is reaction time. So reaction time is what? It is that time in which a person takes to observe, think and act. So whenever you are seeing something, then that time you are taking some instant of time to think and act accordingly to that one. So if someone is talking to you, then what you have to reply, you are taking time in that. So all this is called the reaction time. So for example, if a person is driving a car and suddenly a boy appears on the road, then in that the time elapsed before he applied the brake of the car is the reaction time. Means he thought that yeah, the boy is coming, I have to stop the car. Then this is the time in which he think, observe he observed the boy, then think, then act. So it actually reaction time, you will see that is different for different kind of persons, different types of type of instruments even. So that depends on the presence of mind of the individuals and the complexity of the situation. Sometimes there is no time, even you can think to just to apply the brake, but no of the distance is, then that time accidents will happen. Discussion of these topics of accelerated motion, motion in a straight line, let's end our class here. So in next class, let's discuss the rest of the chapter of this is a motion in a straight line, rest of the topic of motion in straight line. So for today, let's end our class here, guys. Thank you.